Hey guys, we're back with the notes for 10.1. You should be watching this after the Unit 9 test. So I'm going to have you freeze the screen in two different places, copy what you see, and then we'll get started talking about it. So the first place I want you to pause and copy is right here. Perfect, you should have that written down. Second place I want you to pause and copy is this part. Perfect, you should have that written down. So let's go ahead and start at the top. We've graphed exponentials before. You actually should have done this in Algebra 1, just as a matter of whether or not you did it during the school closures. So exponential functions basically have two pieces. Let's talk about the equation. You have what's called the initial value. That tells you where it's starting, and then you have what's called the multiplicative rate or the multiply rate. Okay, so initial value tells you where you are starting. Multiplicative rate tells you what you are multiplying by each time. So we have a couple rules. The b has to be positive and it can't be 1. So if you think about multiplying by a negative, if you continuously multiply by a negative, it's going to jump back and forth. The number is going to get larger, but you would alternate between positives and negatives. For that reason, we are not going to be able to have a negative b. Okay. Second thing you can't have is a b that's a 1. Because if you think about multiplying by 1 over and over and over, nothing would ever change. Okay. All right. So for the initial value, most of the time when you see an exponential function, you will not see the a value. The a value will just be 1. Every single problem right here, 1, 2, and 3, all of them could be written the same way as 1 times 2 to the x. This one is technically y equals 1 times 3 to the x. The a is always going to be 1 if you can't see a number in front of it. And we'll show you what that looks like when you have it, when you don't. Okay. All right. Second thing I want you to know, or third thing I want you to know, is our rules for exponents. Remember that if you see a negative exponent, that does not mean you're making a negative number. It just means that the base that you're raising it to a negative power is relocated. It's moving to the bottom. If it was in the bottom and it was a negative, so for instance, something like 1/4, if I do that to the -2, you would move the 4 up to the top and then make it to the +2, which would give you the number 16. So it inverts whatever your base is. Okay. Finally, x to the 0, anything raised to the 0 is going to give you a 1. So whenever you have a 0 as your exponent, your value is always going to be 1. If you have a transformation, that's one thing. All right, so let's talk about graphing these. I've plugged in the values. I'm basically taking the number 2 and I'm putting it to 5 different powers. So if I raise it to a -2, that's like saying 2 to the -2. We know 2 squared is 4. This is just 1 over 4. 2 to the -1 is like saying 1 over 2 or 1/2. Anything to the 0 just gives you 1. Anything to the first power is itself. We know 2 squared is 4 and 2 to the third is 8. All of those values can fit on our graph. It would look like this. You'll notice that we're still looking at an asymptote, and that's because no matter what I raise that value to, it's never going to be 0. I'm going to keep cutting it in half, cutting it in half, cutting it in half, going this way. So notice I'm dividing by 2 every time. This way I'm multiplying by 2 every time. If I keep cutting it in half, it's never going to be 0. It's also never going to be negative, which means I end up with an asymptote on y equals 0. And we'll talk about that in a minute. Okay. Same thing for these two. You'll notice these two are kind of inverted. So the first one, as I'm going this way, I'm multiplying by 3 every time. This way I'm dividing by 3. Looking on this one, you'll notice this way, I'm using that multiply rate. I'm multiplying by 1/2, which happens to be the same thing as dividing by 2. So if I go this way, I'm dividing by 1/2, which happens to be the same as multiplying by 2. Try to wrap your brain around that real quick. Okay. You should already have these pieces graphed. I'm really just showing you what it looks like if b is a whole number, like number bigger than 1. It's going to be what we call exponential growth. So if I could let me grab a different color. If you are moving away from the x-axis, we call this growth. That's going to happen whenever b is bigger than 1. And that's written on the bottom of your paper. If you are moving down towards the x-axis, we call this decay. It is called exponential decay. You're moving downward, okay? That translates and matches up with this value up here. So if I'm cutting my values in half every time, they are decaying. They are getting smaller. If I am multiplying by numbers by 3 or by 2 every time, they are growing. They are getting larger. All right, let's go ahead and look at the bottom. So you are going to see these in the same format of the a, b raised to the x, but don't forget that we do have transformations. So you are going to have a transformation change just like we normally do, except it's not going to be in parentheses this time. Your x minus c, if you have a c value, it will be raised up in the exponent with the x. Your d value will be anything that is added on to the end of the problem or subtracted at the end, but it will not be in exponent format, okay? All right, so as a general rule, the graph is going to pass through the point 0, a, because if I plugged in 0, b to the 0 would give me 1, and my a value would be 1 times whatever that value is, okay? Now, that does change if you end up with transformations for c and d. Just keep that in mind. You will find it very helpful to make tables for these as a way to guarantee you get all the points right. Second thing we need to know is graphs are continuous. There's no holes or jumps. There's no discontinuity. You are going to just assume that you can connect everything, which makes the domain all real numbers, right? Everything from negative infinity to positive infinity, everything's going to work. You are going to have a horizontal asymptote at y equals 0, most likely. The only time it's not y equals 0 is if you have a vertical shift up or down with d value. So if you want to remember y equals d is your asymptote. We talked about growth and decay a little bit. Let's look at that for in value or in behavior, sorry. As x moves to the right, so as x is going positive, your graph is growth if your f of x is approaching either positive or negative infinity. So let me show you what that means. If here's my asymptote, I could be growth if I'm moving this way or growth if I'm moving this way because I am moving away from the asymptote, okay? Your graph is decay if you are moving towards the asymptote. So as the x gets closer to infinity, you are moving towards the asymptote. Both of these would be considered decay. Whether it's positive or negative doesn't matter. Okay? All right. Finally, for the range, your asymptote is your boundary line. You cannot touch it, which means my range is either from the asymptote up to infinity or from negative infinity up to the asymptote. Either way, your asymptote is the number value that you're using, and you will not include it with a bracket. It will always be a braces. Perfect. Let's go ahead and actually get into some graphs now. Again, you're going to find a table very helpful in identifying these. So we've already graphed f of x equals 3 raised to the x. So just to show you how I'm getting that, I am going to go ahead and go through these guys. So remember, we're looking at 3 to the negative 2. Doesn't mean it's a negative 9. It means it's 1 over 9. 3 to the negative 1 gives me 1 over 3. Anything to the 0 is 1. And then the rest of these, I'm just multiplying by 3 every time. 3 to the first power, 3 to the third, 3 to the second, and then 3 to the third. So 3, 9, 27. Obviously, 27 won't fit on our graph, but we can graph from there. Okay, so 1/9 is really low. 1/3 is still pretty low. And then we're moving up from there. So we actually are only going to be able to fit, I'll put 9 on here just because, but we would even only be able to fit those 4 dots. I'm going to draw this. It's continuous all the way down, not touching the asymptote, which in this case, because I do not have a transformation, is going to be on y equals 0. Okay. All right, so let's fill in what we know. My y-intercept is 0, a, because I have no other transformation, so 0, 1. My asymptote is going to be at y equals 0 because there is no transformation up or down. When I plug in f of 1, that is this guy right here. So f of 1 equals 3. My domain is always going to be from negative infinity to positive infinity, and my range is above the asymptote, so I'm going from 0 up to infinity. Okay, we're done with problem 1. Let's look at the next one. You'll notice that number 2 does have transformations, so as we move through these, we'll want to understand that. One thing I like to do is start with your transformations and make sure you know which way you're going. I know right here that since it says +1, I'm going to go left 1, and since this guy says -2, I'm going to go down 2. So one thing you might realize right away is that my asymptote is going to move down to y equals -2. I'm going to go ahead and draw that on here. Y equals -2. Now, my pattern is essentially going to stay exactly where it was. All I'm doing is shifting those values one space to the left, okay? So I can do it with the table. I can also do it from a transformation perspective. So normally, we would say 0 goes to 1, except in this case, I'm going to move that 1 to the left. Normally, we would say 1 goes to 3. But in this case, I'm going to move that 1 to the left. We would say 2 goes to 9, so 3, 6, 9. But I would move that 1 to the left. If you understand transformations enough that you could do it from that way, that's totally fine. If not, let's show you how we would get these otherwise. Let's go back to our table. Move this just a little bit. All right, we're going to go 3 raised to the -2 plus 1. And then at the end, we're going to subtract 2 from it. So -2 plus 1 is going to give me a -1. 3 to the -3 would be 1 over 3. And then -2 would be like saying -6 over 3. So you're going to end up with a -5/3. It looks really complicated, I know. Just stay with me. If we did 3 to the -1 plus 1 minus 2, -1 plus 1 is 0. We know 3 to the 0 is just a 1 minus 2 gives us -1. Everything from here on out should be pretty basic. Okay, so 3 to the 0 plus 1 is going to give me 3. Minus 2 gives me a 1. 3 to the 1 plus 1 is going to give me 3 squared, which is 9. Minus 2 gives me 7. 3 squared plus 1 is going to give me 3 to the 3rd, 27. Minus 2 is 25. And we really don't need anything outside of that, because even that doesn't fit for us. Okay? All right, so just like I showed you before, you're going to end up at -1, -1. Down here, we're at -1 1/3, basically, right here. 0 is going to go to 1. 1 is going to go to 7. All of that matches exactly what we just had. You are taking your normal graph and moving it down 2 and 1 space to the left. Okay? All right, so that being said, now we know that 1 is going to go to 7. We know that our point is still 0, 1. So we took our A value and then we moved it left 1 and down 2. So that did edit just a little bit from where we were at. Our domain is still going to be from -infinity to positive infinity. And our range is above the asymptote. So we're going from -2 up to infinity. Okay. All right. Let's go ahead and look at number 3. Number 3, I'm going to do the same thing with the table. This time we are going to raise 3 to the value and then double it. Okay, so if I do 3 to the -2, remember that's 1 over 9, and then I'm multiplying it. Ooh, that's by a +2, I believe, right? Yep, sorry. All right, so we're going to end up with 2 over 9. If I do the same thing here, 3 to the -1 is 1/3. I'm going to end up with 2/3. 3 to the 0 is 1, double that. 3 to the 1 is 3, double that. 3 squared is 9, double that. And already it's too large, it's not going to fit. So let's go ahead and graph what we know. My graph does not have a transformation that's moving it up or down or left and right. So I'm staying on y equals 0. Graphing those points, we are going to go -2 and a 2/9. That's very small. -1 is 2/3, getting a little larger. 0 is going to go to 2. 1 is going to go to 6, and nothing else fits. So this is my graph. Okay. So in this case, our y-intercept with no transformations is my a value, 0, 2. My asymptote did not do a transformation, so y equals 0. F of 1 is what we got by plugging in 1 to the equation, so that is giving me right here 6. Domain is going to be all real numbers, so -infinity to +infinity. And then because we are above the asymptote, we are going from 0 to infinity. Okay. All right, if you needed to pause and copy anything on those middle two, do so now. We are going on to the last problem of these notes. Okay. All right, last time we're going to do a table. I'm going to move this over just a little bit. We are going to use 1/3 as our base, but we are also going to make it a negative value because our a is a -1. So right here, remember that a is a -1. Okay. All right, so negative of 1/3 to the -2 power. So think about it this way. You're going to flip it. That's a 3. Square it. That's a 9. And then make it negative. So -9. So flip it is the negative on the exponent. Squaring it is the 2. Negative is the out front number. Let's do the same thing. So 1/3 raised to the -1. So I'm going to flip it. That's a 3. To the first power stays a 3. Then make it negative. So -3. 0. Oops. 1/3 doesn't matter. To the 0 is automatically a 1. We make it negative. 1/3 to the first power is still a 1/3, but I make it negative. 1/3 squared is 1/9, and I make it negative. And then we really don't need the 3 because it's going to be 1/27 and then make it negative. It's going to be super, super tiny. You're not even going to be able to tell from that anyways. So we can skip that value. All right, there is no transformation left and right. There is no transformation up and down, so I'm going to stay on 0. That's my asymptote. Let's go ahead and graph the points we know. So we have -2, -9. And I'm going to go ahead and graph where that should be. -1, -3. 0, -1. 1, -1/3. And then this is super, super tiny with 1/9. All right, so our graph looks something like this. You will notice that even though it's negative, it looks like it's going up, but it is still decay. All right, this is still what we call decay because your values are getting smaller. -9 down to -3, down to -1 is still decreasing. Okay. All right, your y-intercept in this case is 0. What you get by plugging that in, that's a -1. Again, no transformation, so it was just our a value. F of 1 is what we got from plugging in 1. That's the -1/3. Domain is always all real numbers, so -infinity to +infinity. But this time our range changes. I am below the asymptote. So 0 is the highest I can go. -infinity is the lowest. Again, there are no brackets when we're looking at these. So make sure you use all parentheses for domain and range. That is the end of our 10.1 notes. If you missed anything, please rewind.